Now, before we proceed further in this course and we start creating a REST API application using Nest.js, in this lecture, let's dive deeper into what is REST API and when an API is called as a REST API. Now, if you're already aware of what is REST API and you have been working with REST APIs, then you might want to skip this lecture, and that's perfectly okay. However, if you stick with this video, you will learn and understand the different principles of REST API which makes it a REST API. And you will also learn other basic things related to REST APIs. So let's get started. Now, what is a REST API? REST API stands for Representational State Transfer API, and it is a software architectural style that defines how clients like the web browser or the mobile apps can interact with servers to retrieve and manipulate data. It's a very popular method for building web services because of its simplicity, scalability, and flexibility. Any API that conforms to the design principles of REST architectural style of programming is called as REST API. So keep in mind that APIs can also be of different types. And one of the types is REST API. Now, an API is called as REST API when that API follows the principles of REST API. And a REST API has following six principles. It follows the client server architecture. It should be stateless, cacheable. It might have layered system. It should have a uniform interface, and then it can also support code on demand. Now, this code on demand principle is optional, so we are not going to talk about it in great detail in this lecture. But apart from that, other five principles are mandatory for an API to be a RESTful API. And that's why let's go ahead and let's talk about these principles of REST API in brief, and let's understand what these principles mean. And the first one is the client server architecture. When we create a REST API, the REST API follows a client server architecture. It's as simple as that. So when we create a REST API application, there we will have a client which will be responsible for sending a request, and we will have a server which will be responsible for handling that request. So client will send a request to the server will process that request, and it will send back a response to the client. And this is called as client server architecture. So whenever we create a REST API, that REST API follows client server architecture. That means that REST API application will have a client. The client will make a request to the API. The API will be hosted on the server. So when a client makes a request to the API on the server, that API will handle that request. It will process that request. It will create a response, and it will send it back to the client. The next principle is the stateless principle. So, stateless principle simply means that each request is treated independently and the server does not maintain any session state for the client. This means that every request must contain all the necessary information for the server to understand and process it. A simple example would be, let's say you want to get all the users from the API. Now, if you want to get a list of all the users, in order to get the list of all the users, you must be an authenticated user. So before requesting for all the users, you will first authenticate yourself, and then you will make a request to the server to get all the users. Now, in case of REST API, server is not going to store any session data. So once you have logged into the application, the server is not going to store your user ID or anything like that. So every time you are requesting a protected resource, you will have to authenticate yourself with something called as authentication token. Okay, since server is not storing any session data, every time you're going to send a request, with that request, you need to send an authentication token to authenticate yourself before you request for any resource, before you request for any data. So as you can see, when we are requesting for a user detail using this endpoint, with that request, we are also sending the authentication token in the request itself. Okay, so server is not storing any session data. So that's why each time we are making a request, that request must contain all the necessary information for the server to understand and process that request. Since we want to get the user detail is a protected resource and only an authenticated user can access that user detail. With the request, we are also sending our authentication token. This authentication token will be processed by the server to authenticate the user, and if this token is correct, then only the server will send back the response with the user details. If this authentication token is not correct or if it has expired, then the server will not send back the user detail in the response. And server is also not going to store this authentication token on the server. And that's why we say that REST API should be stateless. No data should be saved on the server, and all the information which is required to process a particular request should be sent with the request itself. Then the third principle is cacheability. So when we make a request from client to the server, let's say we are requesting a list of users. So let's say in the response, we are going to get 1,000 users. Okay, so we have made a request to the server requesting all the users, and the server is going to send back a response with all the users. So in the response, let's assume that we are receiving 1,000 users. Now, next time again, if we make the same request to the same URL for same list, then again the server is going to send us back the same response. So instead of doing that, what we can do is when first time we made a request to get all the users and when the server sent us that response, we can cache it. Okay, the client can cache it. And next time if we make the same request to the server, instead of making an actual request to the server, the client will simply get that data from the cache, the response from the cache, and then it will show it to the users. Okay, so this principle states that responses from a REST API can be cached by the client or intermediate servers to improve performance. And this reduces the load on the server and provides a faster user experience. Next principle is layered systems. So REST API follows a layered architecture. What this means is neither the client nor the server can tell whether the communication is happening with one particular application endpoint or many intermediate trees. Let's understand this with an example. So whenever you send a request from the client to the server and at the server end, the request might have to pass through different layers of system before the response is sent back from the server. There could be a Redis cache, there can be middlewares in between, and there can also be a database. And this is a very simple example with few layers. Usually, a request goes through a lot of layered systems before the response is sent back to the client. But the client is not aware of any of these layers. Client has a single uniform API endpoint or interface which it interacts, and it does not care about how many layers are there through which the request has to go through before a response is sent back to the client. Okay, so the REST API should be designed in such a way that neither the client nor the server can tell whether the communication is with one application or many layers. And this is what the layered system principle of REST API is. On the server, when we receive a request, that request might have to go through different layers before a response is sent back to the client. Next principle is uniform interface principle. REST API uses a standard set of HTTP methods, or you can also call it as HTTP verbs, to perform different operations on the resource. Let's try to understand it with an example. Let's say I want to get all the users from the database. So for that, the endpoint will look something like this. So here, this users is the resource. It is the route to which we will make a request in order to get all the users. Now, whenever we make a request consists of two parts. The first part is the HTTP verb or HTTP method. And the second part is the URL or endpoint. So in this example also you can see we have an HTTP verb called get and we have an endpoint. To this endpoint, we are making a request to get all the users. So here we are making a get request to this endpoint to get all the users. Now, if we have to create a new user, in that case, the endpoint will be same. Okay, the endpoint will be still HTTP localhost 3000/users. But this time the HTTP method will change to post because now we want to create a new resource. So as you can see, the endpoint is same, but HTTP method has changed. And this is what uniform interface means. In uniform interface principle, the endpoint or the URL should always be uniform for performing a particular CRUD operation on a given resource. In this case, we are trying to perform some operations on this user's resource. When we are using get HTTP verb, at that time we want to get all the users and display it. When we are making a post request to this user's resource, at that time we want to create a new user. And in the same way, if I change the HTTP verb to delete, the endpoint is same, but now the action will change. Now we are trying to delete all the users from the server. So here, this delete is an HTTP verb which we use to delete a resource on the server. So as you saw, the endpoint was always same. It never changed. Only the HTTP method changed. And when the HTTP method changed, the action also changed. So here we have a uniform resource, we have a uniform interface, but the HTTP method kept on changing based on what action do we want to perform. And this is called as uniform interface principle. Now we have different types of HTTP methods or HTTP verbs. So for example, we have this get, which is the most commonly used HTTP verb. And we use this get HTTP verb to retrieve some data from the server. So whenever we make a get request to the server, that means we want to fetch some data from the server. For example, if you want to get all the users from the database, we will make a get request. If we want to get all the products from the database, we will make a get request. If we want to get the details of a product, at that time also we will make a get request. So whenever we want to fetch some data from the server, at that time we make a get request. Now, if we want to create a new resource on the server, for example, if you want to create a new product or a new user, at that time we will make a post request. And when we make a post request, with the post request, in the request body, we also need to send some data using which we want to create that new resource. We want to create that new item on the server. So for example, if I want to create a new product, then I will send a post request to the server. And with that request, I will also send the product details in the request body. And then the server will analyze that request. It will read the request body, and using that, it will create a new product on the server. So to fetch data from the server, we use get request. To create a new resource on the server, we use post request. Then we also have put and patch requests. The put or the patch request is used to update an existing resource on the server. So if you want to update a product detail, at that time you will send a put or patch request to the server for updating the product detail. Now the difference between put and patch is when we use put request to update a resource, at that time in the request body we will have to pass the entire object. Even though we are only changing one property of that object, we will still have to pass the entire object. For example, if I want to update an existing product on the server using the put request, then I will have to send the complete product object. And in that object, let's say I have only changed the color of the product. So only the color property has changed, but still I'll have to send the complete product object in the body. But using patch request, we don't need to send the complete object. Instead, we can send only that part which has been updated, which we want to update. So if I want to update only the color property of the product, then with the patch request, I will only send the color property and not the entire product object. And finally, we also have this delete request, this delete HTTP verb, using which we can delete a resource on the server. So whenever we make a delete request to a given endpoint, we make the delete request to delete something on the server. So these are the 5 most commonly used HTTP verbs. We also have other HTTP verbs, but these are the most commonly used. All right. And finally, we have this code on demand. So this principle is optional, and this principle allows clients to dynamically download and execute code on the server. This enables client to extend the functionality of the server without requiring a full application update. Now, this principle is optional and it is something which we are not going to use. So that's why I'll not go into the details of this principle, but the main 5 principles which an API should follow to become a REST API are these 5 principles. All right, so now you know what is a REST API and what are the principles an API should follow to become a REST API. Now, let's try to understand the anatomy of a request. So, whenever we make a request to our API on the server, it might look something like this. A request consists of 2 main parts, the HTTP method and the endpoint. Here in this example, this get is the HTTP method which we are using for this request. So basically, we want to fetch some data from the server, and that's why we are making an HTTP GET request. But if we want to create a new resource on the server, we will make a POST request. If we want to update something on the server, we will make a PUT or patch request. And if we want to delete something on the server, we will make a delete request. Then in the request, in the endpoint, an endpoint consists of a domain. So in this example, this http colon localhost 3000 is the domain. Google.com is the domain. Facebook.com is the domain. Okay, so domain is the main part of the URL. After the domain, we might also have a resource or a route. For example, if you want to get all the customers of your e-commerce application, after this URL, after this domain name, this customer is the resource, or you can also call it as route. Okay, then we can also have users as the route. We can have, let's say, posts as the route. We can have product as the route. So this is the route of this endpoint. After that, we can have route parameters. Route parameters are the dynamic part of the route. In this example, this root URL slash customers is the route. And in that route, we also have this value India. Now, this India is part of this route, but this value can change. So instead of India, you can also have USA or UK or Pakistan or Sri Lanka. So this value here, this country name can change. So here this route parameter is the country and its value can change. Its value can be anything. So this is the dynamic part of the route whose value can change. Then in a URL, in an endpoint, we can also have query strings. Now what are query strings? Query strings are the extra data which we can pass to a server with the request. For example, let's say what we want is we want to get all the customers of our application who are from India. And when we are going to receive the list of all those customers, instead of displaying all the customers, we want to implement a pagination. And there what we want is in the first page, we want to display 10 customers. In the second page, we want to display next 10 customers. In the third page, we want to display next 10 customers and so on. So here what we are telling using this URL is, basically using this query string is, send me all the customers who are from India, but don't send me all the customer at once. Instead, send me only 10 customers from page 2. So from the database, API will select the customers from 11 to 20 because page here is 2, and then it will send those customers in the response. If the page is 1 here, then the API will select the customers from 1 to 10 and then it will send those customers in the response. But here page is 2, so the API is going to select customers from 11 to 20 and then it is going to send those customers in the response. So here using the query string, we are sending some extra information to the server for processing this request. Then with the request, we can also send some request body. Now we do not send request body with all types of request. There are some specific request types with which we send a request body. For example, we send a request body with post request because as we learned, using post request, we create a new resource on the server. And to create that new resource, we need to send the details for that resource with the request, using which the server will create that new resource. So with the post request, we send request body. In the same way, with put and patch request also, we send the request body. But with get request and with delete request, we do not send the request body. And request body contains the request data using which the server will either create a new resource on the server or in the database, or it will update an existing resource on the server or in the database. Now, in our coming lectures, we are going to learn about the route parameters. We are going to talk about the query strings, and we are also going to talk about the request body. And we will also learn how to read these values from the request in our Nest.js application. This is all from this lecture. If you have any questions or any doubts related to this lecture, then feel free to ask it. Thank you for listening and have a great day.